Okay, so division. Division of complex numbers. What do we mean? Well, if we're talking about dividing complex numbers, we don't really mean divide. Because when we say divide in the sense of complex numbers, what we're really talking about is when we have a fraction that contains a complex number or an imaginary unit in the denominator. Now, in the most simple case, like this first one, I have 6 over I. Just remember that we defined I to be the square root of negative 1. And if you picture it that way, you'll remember that what we're really talking about is rationalizing the denominator. We're taking 6 over the square root of negative 1. And if you recall, that meant that we would have, in this form, multiplied the numerator and denominator by negative 1 to rationalize the denominator. So really, if you picture it this way, this will help you imagine what we have to do with 6 over I. Well, I would have to multiply by I in the numerator and denominator in order to clear my radical. So I'm going to multiply I times I in the denominator. I'm going to get 6I in the numerator. I'm going to get I squared in the denominator. And remember that I squared is negative 1. So this is like saying 6I divided by negative 1. But in the simplest case, that's really just negative 6I as the result. Okay, well, what about this one? We've got 3 plus 2I over 3I. Well, just like any other radical, if we want to simplify this one, what we should do is that we should multiply by something to rationalize the denominator. It's 3 times the square root of negative 1. So my choice would be to multiply by I. The question is why? Well, in this case, if we take 3 plus 2I, we would distribute I to each term in the numerator, and in the denominator we're going to get 3 times I, which is 3I squared. So to us, this is really like saying 3 times I in the numerator plus 2 times I squared. And of course, the denominator, I'm now going to end up with negative 3. And rewriting this one more time, I'm going to have 2I squared. Well, that's negative 2. We'll be adding that to 3I in the numerator and dividing that by negative 3. Is this in standard form yet? Why, no. What we have to do is separate out the parts of the fractions we're going to get. Positive 2/3, right? Negative 2 over negative 3 is positive 2/3 minus 3/3 I, which is 1I. And so our result right here would be 2/3 minus I. All right, but let's talk about something that's really a little bit more convincingly hard for many people because they have trouble picturing it. When we quote unquote divide two complex numbers in standard form, what we're really doing is multiplying the numerator to denominator by the conjugate of the denominator. And again, picture the situation if this were involving the radical form of I, which is to say 5 plus 4 times the square root of negative 1. In order to rationalize the denominator of the fraction like this one, we have to multiply by the conjugate of the denominator. Now remember that a conjugate is when we take the two terms and we reverse the operation between them. So if we want to take the division here, let me do a little stick math for you. If you keep in mind that this is a radical, this means that we're going to take our expression 8 over 5 plus 4i and multiply both the numerator and denominator by 5 minus 4i, the conjugate of the denominator. But whatever I do to the denominator of this single fraction, I have to do equally to the numerator of this fraction, 5 minus 4i. So I'm going to end up with 8 times the quantity 5 minus 4i. And when we multiply those conjugates in the denominator, remember, we're using that rule that tells us that anytime we take a minus b times a plus b, we're going to get a squared minus b squared. So in our denominator, when we rewrite this, we're going to get 5 times 5, which is 25, minus 4 times 4, 16, I times I. That's I squared. So now, if I distribute in my numerator, I'm going to get 40 minus 32 times I in the numerator. While in the denominator, I'm going to take 25 minus 16i squared. That's 25 plus 16. And we know that's going to be 41. So what we're really going to end up with here looks like this. 40 41st minus 32 31st. Minus 32 41st I. In complex number is a standard form right there. Okay. All right, one last one here. Let's try the same deal. Right, we've got 2 plus 5i, 3 minus 2i. So take a moment. What do we multiply by in the numerator denominator? That's right. It's going to be 3 plus 2i. So we multiply the numerator denominator by the conjugate of the denominator. 3 plus 2i, 3 plus 2i. It's the same thing as multiplying by 1, and when we carry out the multiplication by using the FOIL method in each of these numerators and denominators, take a look at what happens. In the numerator, 2 times 3 is 6. 2 times 2i is plus 4i. Plus 5i times 3, that's plus 15i. Plus 5i plus 2i, that's plus 10i squared. In the denominator, 3 minus 2i, 3 plus 2i, that's going to turn into 3 times 3, 9, minus 2 times 2, 4, I squared. All right, let's simplify and get rid of those I squareds right here. We're going to end up with 6 plus 19i plus 10 times negative 1 divided by 9 minus 4 times negative 1. Replacing I squared with negative 1, remember. We're going to get 6 minus 10, that's minus 4, plus 19i in the numerator. And in the denominator, 9 minus negative 4 is 9 plus 4, that is 13. And so our resulting expression will look like this in standard form, negative 4 thirteenths plus 19 thirteenths I. All right, here you go.